So hello everyone, so welcome to this video. In this video, we're going to understand the concept of taints and tolerations with a perspective for CKA. So what you can expect is from this is that we're going to cover the theory of this topic, then the question, and also the actual implementation. So if you watch this video till the end, then you will be for sure able to solve any questions related to taints and tolerations, and also conceptually you will be very confident about taints and tolerations. Okay, so without wasting much time, let's try to understand what is taints and tolerations for Kubernetes. It's a very easy and simple concept, so you will get to know that. I've done a small diagrammatical representation of this whole thing so that I can explain it to you. So first we'll understand what is taint. So as I've written here, taint is a way to control which pods will be allowed to deploy on a specific node. So it is just a medium so that we can control which pod can be deployed on a specific node. And what is toleration then? Toleration will be used to tolerate. The word tolerate is used a lot, but it means like basically allow a specific pod to deploy on a tainted node. Okay. So suppose you have a node which is which is only to be used to deploy pods that are CPU intensive. So then how would you make sure that those only those pods are deployed on that node? So then taints and tolerations come into play. So what you would do is you would first taint that node with like a key or value pair, like saying CPU equal to high, which indicates that all the pods with high CPU usage only should be deployed on this node. And then how will you make sure that a pod which requires high CPU is deployed on that node? Is by adding a toleration within that pod which specifies that tolerate only nodes that have high CPU usage, so CPU equal to high. So what happens is whenever you deploy this pod, it will only deploy on that node if the node has the taint and toleration on it. Otherwise, if the taint and toleration does not match, the node will not allow for any deployment to take place. But it's not restricted till there. So there are types of taints. So there are three types. One is no schedule, no execute, prefer no schedule. So what is no schedule? No schedule is a very hard and fast kind of way. That is, whenever you deploy a pod and on that pod there is no toleration for the specific node, then the node will not allow that pod to be deployed on that node. So for example, suppose there's a node where you have put a taint as tainted the node with a key value like CPU equal to high, and there's a pod which is being deployed with a different taint or no taint at all. Then what will happen is the node will prevent that pod from being deployed on it because it does not have the toleration. What is no execute? Now let's say that there is a node with already some pods running, and now suddenly you have decided that this node will have a taint on it which says that CPU equal to high. Then what happens is, if you put no execute along with the taint as a taint effect, what will happen is it will also go and check the existing pods which are running on that node. And if these pods do not have the specific toleration, then even those nodes will be evicted. Those pods will be evicted from the node. That is the thing. So in case of no schedule, it will not evict the pods which are already deployed on the node. It will only prevent any new pod from being deployed on the node which does not have the toleration. But in case of no execute, not only will it prevent pods from being deployed which does not have the toleration, it will also remove existing pods which are there on the node which does not have the toleration. And finally, we come to prefer no schedule. All these words are very self-explanatory. Prefer no schedule, what it says is that you are just giving a preference. So in case that there is a node that can be deployed somewhere else, a pod that can be deployed on a different node, then it will make sure that it deploys on the different node. But in case it's a pod is being deployed and there is no place other than this node where it can be deployed, then it will deploy because it has no other place to go. So it will only prevent from being deployed on this node in case it has another opportunity to be deployed somewhere else. But if this is the only node available, then it will not prevent. It will deploy the pod even if the pod does not have a toleration for that node, because it has the prefer no schedule, which is only a preference but not a hard and fast. So here is a diagram where you can see a pod with the toleration position equal to low. So if the pod is having a toleration position equal to low, then this pod can basically deploy on these tainted nodes with the where you can see it has a taint position equal to low, as well as it can deploy on the other pods as well, other nodes as well. So this pod can deploy on all the nodes. But you can see another pod which does not have a toleration at all. So that pod you can see is not, you can see the arrow is only pointing to this node. What it means is that this pod is only capable of being deployed on the untainted nodes because it does not have toleration for any node that is tainted. So that is why this pod can only get deployed on the untainted nodes. Meanwhile, the pod which has a toleration can be deployed on the tainted nodes as well as the untainted nodes. This is something worthy of understanding. Okay, so that is the concept. So now we will understand this better through actual implementation. So for implementation purposes, we'll go through a question which can come in CKA. So let's read the question first. In a Kubernetes cluster, taint the node 01 so that no new nodes can be scheduled on it unless they have a specific toleration. Okay. Then create a pod named test pod using busybox image that can run on node 01 despite the taint. Okay. So basically what we are being asked in simple terms is that there is a node 01 and we have to put a specific taint on it so that only pods with a specific toleration can be deployed on that node. And for this case, they're saying to use a busybox image. So that is what you have to understand from this. And now, with our understanding, let us go and check, okay, with the practical implementation, okay. So here we go. For this, we're going to make use of Killer Coda, first of all, because Killer Coda is an easy way to, do a demo and understand things related to CKA, because it gives you an entire platform ready-made. And also in CKA exam, we can make use of Kubernetes documentation. So I'll keep the Kubernetes documentation open as well. So since I'm going to start with this, first I will, as a good practice, go and type cheat sheet over here. And in cheat sheet, I will go to quick reference. All I'm doing over here is I'm just going to get this alias set. So in this cheat sheet, you can find this. It's just easier to just set it up. So I'll just go here. I will paste it. Okay. So we have set the alias. Now let's do k get node. Yeah. So there are two nodes over here, as you can see. One is control plane and one is node 01. And we have to do this taint. So let's go here and just directly in the documentation search taint and tolerations. So we are searching taint and tolerations, and we can go here and you can see the command. Okay. So we know that we have to prevent anything from being scheduled. So for that reason, we will copy it and we will go to our playground, and we have to do this for node 01, right? So let's do it for node 01 and we will write. So we can see the taint nodes and the name of the node and the key value pair. So let me just give it like, for example, CPU equal to high, because that's like a realistic scenario which can actually take place, right? So let's see. Yeah. So we have deployed a taint on the node. And how do we check this? So let's say k get k describe node 01. Okay. So I'm describing the node, and in this you can check that the taint has been added inside the node. So you can see CPU equal to high, no schedule has been added. Okay. So now that we have done that, let us see how this behaves, right? So if I do k run, let's say nginx pod, I'm just going to make one nginx pod for conceptual purposes, and I'm going to put image equal to nginx. Okay. So this is all. I'm just trying to invoke an nginx pod. If I do this, an nginx pod has been created. So if I do k get pod, I can see that this nginx pod has gone into pending state, right? As you can see. So if I go and do k So why has Nginx pod gone to pending state? So now we are going to try to understand this, right? So now I will first delete this pod. So k delete Nginx dash pod, right? Sorry, I forgot to add delete pod. Yeah, so Nginx pod is deleted. Now what we'll do is, let me try to create it again, but I'll do it this way. K run Nginx dash pod image equal to Nginx. But I'm going to try to access the YAML for this. I'll show you how imperatively you can access the YAML. So first what you do is you set a dry run. So this is just a dry run, it's not an actual run. Client. And then we will output this into a YAML. So to output it to a YAML, you use the OYAML command. And then maybe we put this arrow to show that onto which file you will output it. So I will put nginx pod.yaml. So this is where I want my data to get stored. So k run nginx and then image equal to nginx. Then we are going to, we'll make sure that we get the YAML without running. Now if I go into this specific YAML, nginx, you can see that this is the YAML which has been set. Okay. So we have not set a toleration for this yet. So we will see how it works when we set a toleration. So we can go to our documentation for the actual syntax of how the toleration will look, and we can copy this from here like this. Let me copy it and go back here, and we press I for edit. So it is added in spec in containers, so after containers, so in the same position as containers. So I'll go down here, and here I will press enter, paste. Yeah, so here is the tolerations added in the same level. Then the key, our key is CPU, and in our case it is equals. So we will check for the syntax for the equal. So equal, so we have put equal to sign, right? So we will put equal, and we have to add a value as well. So our value is high. Yeah, so we have added this, and yeah, that's pretty much it. And then I will press escape. I think I don't need this resources over here. Yeah. So yeah, so now the difference is that I am adding a toleration with the name CPU with the operator equal and the value equal to high and the effect equal to no schedule, which is matching with the taint which we have just created. So now if I press escape, I press shift and I close this file, and then I can apply this file as k apply -f this way. So I'm applying it. Okay, now if I get k get pod, you can see that it is doing container creating. I can add --watch over here to wait for it to, it's running. Okay, if it's running, I will just check where is it running. K get pod o wide. So you can see it is running on the node which we have specified. So now one more question that will come is, how do you untaint a taint, right? If a taint has been created, how do you untaint it? So you can just simply do the same way, k taint node 01, and what had we given? CPU. Wait, let me see the syntax first of all of how to taint. The same syntax you have to follow. So yeah, so CPU equal to high, and it was a no schedule. So yeah, wait, let me just do Okay, I just want to verify. So if let's just look at the taint first of all, because CP equal to high, no schedules. So have I done the same thing? Oh yeah, I think I have to do something. Wait. To add, I think I have to add a dash. I don't recall. At the end, I think it's at the end. Just give me a moment. I'll just verify this and then I'll let you know. Okay. Okay, so this is what you do. You add it close by, I guess. No. Oh yeah, sorry, my bad. I have not removed it over here. Yeah. Yeah. So yeah, I was mistaking where the dash has to be added. So it has to be added at the end, close by. So yeah, so when you do this way, you can see it says that node 01 has been untainted. So that is how you untaint it. So this is all you need to know, that how it works. So also one thing you can go and try out is for no schedule, this way it works. So for no execute, what you can do is you can first, before tainting, you can deploy some pods on the node. And then after you've deployed a pod on the node, what you can do is afterwards, you can add a taint to it with no execute as the effect. So what you will notice is the moment you do that, the other nodes will be evicted and go in pending, other pods will be evicted and will go in pending state. And if you put prefer no schedule, you will notice that the behavior will remain the same and there will be no change. So that is something you can try out. And also, that's it for this. I would recommend you guys to also go on Code Cloud, on Killer Coda, and do this on hands-on, so that you also get an idea of this. So that's it for this video. If you found it helpful, please subscribe and like this video. Thank you.